Are operators so fundamental as to require operators to always operate by operators? Well, I would argue that operators are inherently active, so they're always moving. Thus, the combination of two operators is another moving process. If the combination of two operators is not a moving process, then those operators are separate. And taking operators as fundamental, there should be another operator connected to this operator, and another operator connected to the second separate operator, creating two separate systems of operators. Here, I'm positing that an operator can take something to an object or a collection of objects, and it can take something from an object or a collection of objects. That creates a set of commonalities between the set of objects that the operators deal with, suggesting a one-way resonance. I'm calling this quasi-stable, meaning that it is possible to generate this diagram for passing something to an object, which in turn, objects shouldn't be processes too. They're supposed to be separate. This is a process of change on an object this is assuming epsilon sub 2 is of infinite size. Assuming I'm not going to call it epsilon 2 because all objects are distinct. So if it pulls from an infinite collection, then this epsilon up here is stable. But if it then again maps to an infinite object, what can we say about the usefulness of what it generates? Anyway, in all of my arrows here, I mean it's carrying something that is distinct. That means that once it leaves one point, it's no longer in that point. So when I write epsilon, these are objects and they must be different. So I don't have to put subscripts on them. So it looks like things start to get interesting for operators and objects at a size of 4 for static cases and what I call stable or quasi-stable operations because they pull from one object to another object. But operators operate on things and they must operate on other operators. So for operators, these operators operate on each other through the epsilon in common used as storehouses for the inputs of the operations. And if we're smart, it won't be random. But mathematically, given the sizes of inputs and outputs on operators like this one, this would either deplete some epsilon or the system would fail. It would fail to have enough energy to allow this process of taking something and putting it somewhere, unless this process has resonance. And so this is going to need to have some resonance that flips the arrows and starts to rebuild the process possibilities for the epsilon. Actually, it looks like shit. So here I'm allowing the process to change, but it eats up my object.
2 o'clock.
Yeah, I shouldn't have called that a resonance because it's being depleted. I'm going to let it be that it passes an object. So it's all back to objects now. A process passes an object to a process, and it's always distinct because it's an object being passed. But these objects are also distinct. Ideally what I want is, and if it's not infinite size, this is what I want ideally, where E star is infinite in size. I want that this mapping leads to this mapping.